Hi, welcome to Physics Teacher. In this video, I'm going to go over a lab that I do with my grade 11 chemistry class. If you want a copy of the lab, you can find it for free in the description. Now this lab has two parts. The first is I'm going to show you how to use a volumetric flask to create your own solution to a specific molarity. And in the second part, we're going to demonstrate a nice slow double displacement reaction. So before we can make our solution, we need to figure out the mass of copper 2-sulfate pentahydrate that we actually are required to make this 0.1 mole per liter solution. So let's start with our concentration equation, where concentration equals moles per volume. Now we know the volume and we know the molarity. Capital M just stands for moles per liter. So that's the concentration. We need to figure out how much of the copper 2-sulfate. So we can start by figuring out how many moles is required, which is concentration times volume. So when we plug things in, we'll change 100 milliliters to 0.1 liters. So we have 0.1 moles per liter times our volume, which is 0.1 liters. And that gives us 0.01 moles of copper 2-sulfate pentahydrate. Now once we know the number of moles, we can use our equation where the mass equals the number of moles times our molar mass to figure it out. But we need the molar mass for copper 2-sulfate pentahydrate, the crystals that we're actually using, not just copper 2-sulfate. Once we dissolve copper 2-sulfate pentahydrate, then we have a copper 2-sulfate solution. But we need to consider the molar mass of that pentahydrate. So copper 2-sulfate pentahydrate has the equation CuSO4 and 5 water molecules. So when we're calculating the molar mass, we're going to need 1 copper, which is 63.5 grams per mole, plus a sulfur, which is 32.1 grams per mole, plus 4 oxygens, so plus 4 times 16 grams per mole, plus this is 5 times H2, so 10 hydrogens, so 10 times 1.01 grams per mole, and then a total of another 5 oxygens, so plus 5 times 16 grams per mole. And that gives us a total molar mass of 249.7 grams per mole. So now we can go ahead and calculate the mass. We have our number of moles, 0.01 moles, times by molar mass, which is 249.7 grams per mole. And we get a mass of 2.497 grams. So let's go back to our experiment. Alright, so let's start by measuring the exact amount of copper 2-sulfate pentahydrate that we need. So we'll take this empty beaker and I will zero the scale. And then we need 2.497 grams. So let's do that. Alright, I think that's as good as I'm going to get, but that's fine. So we got 2.499. That's alright. Now what we're going to do is, using distilled water, we're going to put about 50 milliliters in here. Even though we want a 100 milliliter solution, we're going to start with 50 and we'll build to 100 because I can always add more, but I can't take away, because if I take away, I'll be taking away some of the solute. Okay, you don't have to measure this part very accurately, just roughly is good. And now we are going to stir in order to dissolve. All right, so once it's fully dissolved, we're now going to use the volumetric flask. Now, a volumetric flask makes one measurement and one measurement only. You can see this one says it measures 100 milliliters. And on the glass, we have an etched line. That line is what we need to fill to. We cannot go over that line because we cannot remove any of our solution. We can add as much water as we want, but if we remove some of the solution, we're removing some of the solute. And that we did our best to accurately measure the exact mass that is required. So what we need to do then is pour all of this into here. You can use a funnel to make sure we don't spill. And then what we're going to do is we're going to add more distilled water to our beaker, washing off anything that might be on the stirring rod, and washing off anything that might still be in the beaker. And then we will again pour it through. Do this a couple times to try and make sure you get as much or as all of the solute if possible. Okay. You can even go one step further and rinse off inside of your funnel. Once you've done that, you can add more distilled water until you reach that line. Once you get close to the line, if you like, you can add some into the beaker and then finish off with an eyedropper. All right, next you want to make sure it's completely mixed, so you're going to cap it. And then you're going to mix it by inverting. And now we have a 0.1 molar solution of copper 2 sulfate of 100 milliliters. Now let's do our double displacement reaction. So in this Petri dish, I'm going to add a very small amount of water. I'm going to add some of my copper 2 sulfate solution. And the ammonium hydroxide. We can mix them together. So I hope you enjoyed that lab. And if you work out that double displacement reaction and check your solubility table, let me know in the comments what that precipitate actually was. And don't forget to subscribe so you don't miss the next experiment where I'm going to show you how to dilute the solution.